So first of all, I'd like to say good morning to everyone. I want to cover just for a few minutes. Let's see. Yeah, we have about 30 minutes. I want to cover object-oriented programming. It will be centered around Python. Python is an object-oriented language, but it's also going to entail my Dunnington Best Practice Methodology approach. It is a trademark approach. It's used in a professional environment. I mentioned it yesterday. I worked with the engineers at Lockheed Martin on the F-16 program. They needed a methodical way for everyone to write code. It was for C++, but it's an object-oriented language like Python, as well as Java and C#. So what is OOP? OOP helps you to organize your code. It's much different than procedural types of languages to where you have to go from top to bottom. In an object-oriented environment, you're creating your entities, you're creating your classes, you're grouping your information and your behavior, and then you're actually writing your logic. So you're doing some setup, you're building a class hierarchy. You're looking at all of the participants that should be there, and you create that first. The DBPM provides a systematic approach for you to do analysis. Number one, you have to know what you're going to be doing and why you're here. Number two is the design. Now that I know why I'm here, what should it look like? How should I do it? Number three is the development. That's the final part. How do I implement it? So that's what we'll take a look at today. You got to understand what an object is. You have to understand what a class is. Those are very, very important. Hold on, a new message just came in. Ready? Okay, sounds good. So you have to know what object-oriented design is. It's really modeling the real world. It's much like gaming. You see something out in the physical world, and you're trying to model that with software within a computer to make it available and have human interaction and automation. So anything that you're creating, in most cases, it's a user-defined class. It's a template that you'll be creating. It allows you to identify what entity is responsible for what they should do, how they should do it, what information they should store. We call those attributes. What they should carry out, what functionality they should do. Those are behaviors or methods. So if we can break it down into small autonomous pieces of code, then we can have them to collaborate with each other to build a greater system. So the code benefit leads to more modularity, reusability. Once I create something, like for instance, a car, I can create a specialized car like a Ferrari. Well, I can reuse all the behavior functionality that's in the car. We call that an inheritance, one of the key components in OO, inheritance, composition, polymorphic behavior. It's a Greek term for many forms, many ways, many forms to see something. So we'll take a look at that. The DBPM approach says, okay, here's OO, but how can I have a systematic way of implementing my complex solutions? Well, we have three phases. Phase one is that analysis phase. You got to ask yourself the question, why am I here? What am I doing? So what we do is we create what's called entities. We create entities. Entities will eventually become classes. Entities will have attributes. They will become data types. Entities will have behaviors. They are called methods. So I'm going to stop right now and get some feedback from you. If I'm going to create a summer program for TCC where you're going to learn about STEM, name me three entities that must exist in the real world for that program to happen. You can shout it out or you can type it in the chat. You know what? Let's do it better. Do this for me. Type it in the chat. Type it in the chat. Give me 3 entities. Give me 3 entities. Phase 1, we're doing analysis. We want to put on a program. And it's called the TCC Summer Program for STEM. What 3 entities must exist? A entity is a person, a place, or a thing. It's a noun. The campus. Thank you, Miguel. Give me 2 more. So there is an entity called the campus. Remember, you're mimicking the real world. Someone else. Professors. Thank you, Joanna. Administrators, students. All right, you guys got it rolling in. Great. So let's just stop right there. So I have 1, 2, 3, 4 entities. They must exist in the real world. We're mimicking those. Well, I'll show you how to do that in Python. Create a class. Remember, an entity becomes a class. A class has 2 things: attributes, information it can store, behaviors, things that it can do on that information that's being stored. Make sure you understand that. That is the object-oriented approach. Create an entity. Entity has information it can store. Entity has behaviors it can perform on that particular data. So I'll say it one more time. The OO approach is to have an entity. An entity will have attributes, information it will store, and then it has behaviors that it will perform upon that particular data. Those will become classes. We use the keyword class in Python to make that happen. Now, we'll talk about attributes. No, you know what? Let's go ahead and talk about that now. So give me 1 behavior. Let's go behavior. People get attributes and behaviors confused sometimes. Give me 1 behavior of each one of those entities that you guys told me about that will eventually become classes. So TCC campus, what is a behavior? That's a little obscure, but maybe you can think of it. Well, TCC campus, no, that's building. That's more of a noun. It has a doing work. Excellent. Behaviors are typically verbs, adverbs of verbs. So doing work. All right, give me another behavior like for a student. Well, student could be doing work. Matter of fact, doing work could work for all of them. Yeah, learning. Excellent. So you would have a method called learning in the student entity or class. Walk around campus. That could be a behavior for both students and administrators. Guess what? If we added another entity called people, and then people would have that functionality to walk around campus, then we could have something like administrators and students who are children to people, and they get to inherit that functionality. That's phase 2. Phase 2 says an entity relationship. Now that I've created my entities, now I want to know, is there any relationship between the campus, the student, the administrators, and you guys gave me another one. I don't remember the other one. What was the other one? And the professors. Okay. So an is a relationship is a parent-child. Think of it this way. You exist as a child because you have a parent, which tells you what? Some fundamental concepts. The parent must exist, must be defined or created before you can create a child. Does that make sense? I hope you're shaking your heads. Absolutely. It makes sense. So that's an is-a relationship. In this particular case, there are no is-a relationships. The TCC campus building is kind of an entity to itself. Students are entities to themselves. Administrators are entities to themselves. Let's see, what else? Administrators, those are just 3. Yeah, those 4. So there is no is-a relationship. So I'll give you an example. If I wanted to create a is-a relationship, I would say employee. If I say an employee, then I could create a more specialized entity called professors. So now I can say employee would be the parent, professors would be the child. And I would say it this way, a professor is an employee. Now, could the employee class or entity be a parent of TCC campus? Yes or no? Guys, give me thumbs up, or do you have a thumb down? Shake your head no. Thumbs down. You're absolutely right. It doesn't fit. It doesn't fit. Okay. Can an administrator be a child of the employee parent? Thumbs up or thumbs down? I'll give you guys another guess. I'll give you another guess. Thumbs up, right? Administrators are employees. Parent-child relationship, right? And administrators are specialized at administration, but they're an employee of, Jonathan said, wow, yeah. So that's is a relationship. That's is a relationship. Miguel said that's hot. Got you. Okay. So let's talk about this other entity relationship. It's called a has-a relationship. It's a composite relationship. It's when a entity is an attribute of another entity. It's complexity. It's composition. That's what we're looking at now. When a entity is an attribute of another entity. And an attribute is values can be stored in or utilized. So let's take a look at these four, and I'll see if it fits. So let's take TCC campus, and we're talking about a hazard relationship. Does a TCC campus have professors? Yes or no? Thumbs up or thumb down? Absolutely. So in my design, I would say that's a hazard relationship. TCC campus has a professor. Does TCC campus has an administrator? Absolutely. Thumbs up. Thumbs up. Does TCC campus have students? Absolutely. Thumbs up. Thumbs up. So in this case, we have a TCC campus that has three complex relationships because they have professors, administrators, and students within it as attributes. So that's phase two. Is a parent-child, a has-a is composition, complex data types. Number three is actually the development and construction. 1 and 2 are just the setup. You have not written any logic, hadn't written any code. It's like you're getting all the material together in order to build a building. So now if you get through with phase 1, phase 2, then you'll see we'll get into phase 3, and phase 3 gives you the capabilities of then starting to write your program. All right, so, and it's 9 steps to doing that in this phase. Those are the 9 steps. We'll spend the semester talking about them. I won't go through it in detail today, but I wanted you to know that you'll get this document. It talks about phase 1, phase 2, phase 3, what happens in phase 1, what happened in phase 2, and the 9 steps that happen in phase 3, and then in the actual logic of running your application to make it do something. Okay? So just know we'll do a little bit about the construction today, but we'll get into more details later on. So here's an example of creating a class. I want you to make sure you can get to your environment right quickly. We want to try to do some work today, and we want to go and create a class in Python. Here's an example of how you create a class called dog. But understand the concept of a class. Remember, those classes come from entities. You have to identify entities in phase 1 of the analysis phase. And that entity is also created now with the code in phase 3 of the construction phase. So a class acts like a template. Now, a class is not alive. Only objects are alive in memory. A class is a definition. It's much like a classification of animals. If I said that there's something that has 2 eyes, 2 legs, generally takes 9 months to be born, they're warm-blooded. Okay, I'm giving you definitions of a classification. Would that be a mammal, a reptile, or a fowl? Someone put in the chat. Yeah, so the question is, if I gave you this description of an entity that is born warm-blooded, has 2 eyes, 2 ears, 2 legs, it would be a mammal. Absolutely. So that's a definition or description of a mammal. But now I would say, now give me an instance of a mammal. Someone give me an instance of a mammal. Since now you know how mammals are classified, or you created a class definition, now give me an instance of a mammal. Give me a dog, absolutely. Give me another one. Come on, someone beside Joanne. Joanna's doing great. Miguel, a platypus, all right? Absolutely. So understand the difference between the mammal being the class, which defines what it looks like, which defines how it behaves, which defines its characteristics, versus a dog, which is an instance of that. You can look at a dog and based upon its characteristics and behaviors, you know it's a mammal. So what do you have to do first? You have to create a class first. Class must be created first. So in Python, how do we do that? We use the class keyword, class dog, followed by colon, and that's all you do. Now at that point, it doesn't do anything because you hadn't created any behaviors and you hadn't gave it any attributes, but that's really all you do. And after that, I could say class dog colon, and then I could put a word called pause, P-A-U-S-E after it, which means that I'm gonna come back and define it later on, okay? But in this case, just to fast forward, what you're seeing that we're doing is, this is a class called dog. It has a definition, a method, called an initializer. The actual OO term is a constructor, which says what? When I get ready to take the dog classification and I get ready to create, and then I get ready to create a type of dog, German Shepherd, that's an instance of a dog, I'm going to initialize that object, that's the real thing that's alive, in memory with the name and with an age. And by the way, I'm going to give it a behavior to allow it to bark. So now when I say German Shepherd dot bark, it will come to this class, find this behavior or method, and would say roof roof. Now when I create the dog, when I get ready to create the dog, it will call this class, this method, and it will allow me to pass in the name of the dog, whatever you want to call the dog, and the age of the dog.
Can you just help me out? Can you help me out?
Yes, I can hear you. but I didn't understand you. You may have to type it into the chat.
Oh, think it's wrong.
Yeah, because you guys, your audio is a bit muted.
Got it.
Okay. So if you ask me a question, how do we instantiate an object? How do we create an object? What I can do is go over here, show you an example. Here's the class jet, so we know that's the class, right? And you see that here's the constructor, it's initializing it. If I come down here and I said, let's create an object, all I have to do is simply say jet1. That's my instance. And it's created, and I pass in the name of the jet and the speed of the jet. In this case, this would be dog1, or you could call it my pet. And in my pet, you would call dog the name of your dog and the age of your dog. That's how you create an instance of that class. Okay. Did that answer your question? Someone give me a thumbs up, thumbs down. Thumbs up. All right. All right. So you'll actually get to see that later on. So you have to have a class first, but it's a definition. It must exist. It's a definition. Objects will be created later on. This is in phase 1. Phase 3. We've talked about the is-a relationships, that inheritance relationship. You have a parent class. All right. Like, for instance, a person. It's a class. It has attributes and behaviors and methods, but it's called inheritance. It's called inheritance. Parent, child, parent at the top, child at the bottom. We often say is generality, specificity. He said again, generality, specificity. I'll take a general class and then I'll make a more specific class that does more work. So for instance, when I work with Lockheed Martin, we'd have weapons. Weapons was a very general class. It was a parent class to many things. Now name me a type of weapon. And I can say in my behaviors that weapon can shoot. Yes, Sandra, I am recording it. That weapon can shoot, that weapon can fly, that weapon can sail in the water, right? I can put all those behaviors up there. And now with Miguel comes back and say, but here's an AR-15. Okay, it's a AR-15. It is a type of gun. So that gun inherits all the functions and features of the parent, and then can have its own special features and functions. Like for instance, give you guys a good example. You guys have parents. Do you act like your parents want you to act all the time? Thumbs up or thumb down? Do you act like your parents want you to act? Be honest, Miguel. All right. No, you don't. But if your parent had a class, there's a set of behaviors in your family, right? There's a set of behaviors in your family. They expect you to inherit those behaviors. But then as a child, you have your own specialized behaviors, right? That's inheritance. Inheritance says I get everything that my parents have, but then I get to create my own. I even get to, here's a OO term, I get to override my parents' behavior. So when you're doing something you're not supposed to be doing, then you are overriding the behavior that the parent had given you. Wow. You guys are objects in action. Is a relationship. Okay. So how do we do this in Python? In Python, very simple. Let me ask you guys a question. Yep. I got 9 minutes. Okay. So in Python, to create an is a relationship, all I have to do is pass in the parent to the child. Now I have everything that that particular parent has. So let me ask you this question. How many classes do you see on the screen? One or two? Give me a thumbs up if you see two. Thumbs up. Yes. Yeah. So there are two classes, one called person, one called student. And it's not because person is above student that it makes it a parent or child. It's because when I define the student class, it passes in the person. Now I get everything that the parent is. And if I want to initialize the name, I use something called the super behavior to, hey, tell the parent to name the name way up here, and then I have my own attribute called student. So the other one is composition. Composition, remember, complex objects. Like for instance, a car. A car has an engine. Engine is complex. A car has wheels. Wheels are complex. All right. That's different than car and speed. Speed is a primary attribute that I can define as a number, as an integer. But I can't simply define a engine with a number or with a string. It takes more attributes for that. So that's where we get the complex object. And that's a hazard relationship.